Welcome back to LearnPiezo.org. Today we're going to continue using the Picoscope to program a characterization sequence to determine the impedance analyzer or equivalent, which would be measuring the change of impedance of our ultrasonic piezoelectric device over the frequency. So we're going to be introducing, because last time we were able to do this, we did find out the change in impedance or the impedance trend over the frequency, and we saw there was a there was a resonance, there was a typical, at lower frequencies, there was a typical behavior of a capacitor where the impedance decreases gradually as frequency increases. But today I'm going to show you how to make all that into a graphical user interface so you can interact with the code in a lot easier way, as well as other people can use your program more intuitively, similar to how a LabVIEW program would turn out. So again, here's our basic setup. It was explained in the last section, part 1, Project 1, Part E3. This diagram was explained. This is actually just a slide from before. So today, I'll just explain what we're going to do. So first, I'm going to show the program, which includes the user interface. There are two separate portions. One, we build the user interface using Qt Creator, or I think it was Designer. And the second step is that we use the template for the Python UI, user interfaces UI interface, or you could say connection, and then you would sort of populate the functions and the effects that the buttons and text box perform. So let's just show. Okay, first let's create the user interface. So I'm basically going to go in my C drive where I have my Pi Windows. So go into the C drive. Okay, so here we go. Here's my C drive where I have my Windows Python 64-bit there. I have all of these set up, and as I remember, you have to open your Spider with administrator privileges. But in this case, we are going to open Qt Designer. So double click that, and it will open Qt Designer, which is like a external builder for the interface, which we'll use. And then after that, after we design what the user interface looks like, we're going to create a we're essentially going to create links and what those buttons do. So when you open the program, it looks like this. You just press create. I'm going to lower the let me just fit this little back again into the screen, which I am using. Okay, so we have our main window here, which is it's pretty a little bit small, just because just because I'm shrinking the size so you can see everything. But essentially, what we're going to do is we're going to create a button, which is start, and then we're going to call that button, and you just decide the start, let's say button, and then we're going to put some labels and text bars. So we don't want text browser. We'll put two labels. it's the frequency, for example. And I'll put another label. We'll call that stop frequency. And you see where I'm sort of going here. And then I'm going to put another label and write interval frequency. And then I'm going to have to actually put labels in there. So I would like to look for text. So that we can just look at that. That's two line. Okay, we want to go for line edit. So we just put that there. And then we create another one for the stop frequency. We create another one for the interval frequency. If you look at the top, let me just try to squeeze this back. If you look at the top, you'll see some of the arrangement sequences. So you can just put that, and you get it nice and arranged. You get the start here. What I actually will do, I do rename these. So for example, I'll write start frequency input, and I would change the stop frequency input. I would change this object name to interval frequency. I already changed that. The other thing I want to do here is do plot. The plot we use is plot widget, this one. So just throw that in there, and then it puts in a plot. So this is the UI that we do. This if you save this file, it's going to create a file, whatever you called it, .ui. So instead of saving it, I'm just going to open a recent one, which I called Picoscope for UI.ui. So this is what I actually have. And I had another one for file name. So if you had that line edit, and this is the text box function I'm going to be using, line edit, so I just drop that in there, and you start, and I have this, and each of these, as you can see, are having their specific names. Int frequency, input, stop frequency, you describe things, how it's called. This window is called main window. So if I just want to preview it, I just press preview, and it gives me this. So this is what it should look like when I actually use. So I'm going to put my file name, or whatever I want to, 10K, kilohertz, going to 70 kilohertz and kilohertz, and frequency steps is 1000 kilohertz, let's say. And let's say if I press start, it should have done the same thing that my last program did, was it iterated, and that's exactly what we wanted to do. So we just created a simple program with the user interface. It doesn't actually do anything. Start doesn't do anything for our Picoscope. So now I'm going to open Spider, and I'm going to open a previously already created folder, or already finished UI program. So there's going to have to be a couple of portions in this. So I would say there are, like I was mentioning here, there are going to be different sections of code. The first section of code is going to be your import packages for UI creation. I believe that's what I had here. So no, sorry. The first thing is going to be create a P file from the .ui. So I mentioned that if you save the file from Qt Designer, you're going to get a UI file, which is not something which is inherently works with .py. But if you do this conversion, it will work. So basically, I'm going to do the conversion from Python. A lot of people, they would go in and they do the conversion from the command line. But if you want a sort of more seamless integration between Qt Designer and Python, whatever IDE you're using, then you may want to do that transformation from the UI to the PY in Python itself. But I found that it's very handy. It gets to be a lot more like LabVIEW, which is a good thing. The next part, what we do is you import your packages, and this is pretty standard. The next part, what you do is you import your UI. Okay, so this is actually right here. I'm gonna just put a couple stars before and after. This is where you edit. Usually this other part is going to be more or less the same. Where I'm going to put stars is where you actually go and edit things. So this import packages is fairly common. For the case of this thing, I also made a file. Oh, sorry about that. I also made a file. So import your custom packages. And it has your Picoscope functions. It has a Picoscope. So then you import your UI, which is going to be a standard thing, which is a slight change in one of the names of the process. The next thing we're going to do is another custom. You should define your functions, and these will be mainly your button functions. What do the buttons do when you press the buttons? How do they take the information? How do they change it? So define those functions, and the other thing that you do next is you link the button functions, and here you do and other functions. If you have other functions you want to define in your UI, that's fine. But for most of the Picoscope functions, I'm going to import them as a package, and you'll also see how you do that. I'll explain it. So you link the buttons to the functions the functions that you just defined earlier, and then you just close out your application. So there are you could say six components to this file. You could say 3 of them are what you need to worry about per se, but the rest you should be able to pretty much create a template and use that template throughout. So here's my file. Here's section 1. So I'm actually going to label these sections in sections. So right here, section 1. So I'm just going to help you. Section 1. Create PY from .ui. I'm just going to re-comment it so it's easier for you to call. So we import this OS package, and we perform this function, PyUIC4 space Picoscope, the UI file, to become the UI.py. And what this function here does, this is a command line function because we're actually calling the command line when we do this os.system, and we're passing this statement to it. When you pass the PyUIC, it's basically a protocol which changes the UI into something that the Python can implement, which is the .py. Here, we do a delay. Perform delay, because this command is actually operating in the command line, which is separate than the main Python program. So therefore, because it's separate in the main Python program, we need to wait a little while. I said 2 seconds is usually good enough for any UI to compile, so that when we go to the next step, we will be missing that .py file, or at least the most recent one. So whenever you want to run your program and you make any changes in your UI, you have to save your UI. There's a star here if it's not saved, like if I just change this. You have to save it in order for this to load your newest UI. So that sort of also helps streamline. Because I implemented that section 1, it helps streamline. Section 2, which is package import. And a couple of these packages, they're just left over from previous things. CS interact with the NI instruments Visa utility, but we're not using it, so you could just delete it. Or better than deleting it, you could just erase it. We import the system, which I'm not sure if we need it yet. This here, and I'm not sure if we need this time here either. I don't believe I include time in a function, so I'm just gonna comment those out. So we import functions as fn, and if you know about Python functions or Python packages, this functions is not a package. Basically, I encapsulated all of the previous functions we used to interact with the Picoscope through a different Python file. And this Python file only has functions in it. If you notice, it looks a lot similar to the previous files we used to which we ran, and those actually did our characterization. Now, if you see at the very bottom, I commented out all that stuff that actually does the characterization, and we are left only with the functions themselves. So when I later call, after I import functions as fn, anywhere in the full file, I can write fn dot, and I can use any of these functions. So I can write fn dot signal generator, and I can call that function, and you're going to see that later in the file. So this is just a general file. I'm going to this will be copied and uploaded, but I think the main thing I want to draw attention to is nothing. I think it's pretty much the same. I just commented out the end. I commented out see this initialization and iterating. I just took all that out. So let's go back to here. Our py from the UI. So we did the section 1, we did section 2, package import. I'm just going to delete that. And I'm just going to put a comment here and saying this is our custom functions. Next, we're going to go into section 4, which is the UI import, meaning the Python, the user interface. I'll try GUI just not to confuse with the UI file. The GUI import. So this is this general code we have to use. And remember, you have to change this every time. So this is something you need to change. Change the file name. Import Picoscope underscore UI from UI underscore main window. That's something you don't change. As long as you use the, see, this is called main window here. Don't change these names or it won't work. You can play around with it and understand it later. But for this tutorial video, we're just going to leave this as is. But you have to change this. And as I think I mentioned, all of your files have to be in the same folder in order for you not to have to map out where your different files and functions are. This is also a very standard thing. This is you'll never change that. Okay, function definitions. I really have no custom functions which aren't related to buttons. So let's just go back to that notepad file. Define your buttons function and other functions. I just define button functions pretty much. So this had to be section 5, right? I define a buttons functions. So this is only one here. I have only one button, and it's just called start. And now what I'm going to do, this is actually a very important part on how to implement all, we put numbers here. How do you get that into the Python file? And how do you use it and use that to run your program? Because those are the parameters which you want to change, and it's very important that we implement them. So if you can see here, it's going to be very similar outline and compared to what I commented out here in the functions file where we iterated. I just commented it out because we didn't need to use it. So we start by importing the text box in the start frequency input text box. So that's the start frequency input text box. If you notice, it's called start frequency underscore input. And here we write start frequency, which is a variable and defined in this function, equals UI. This is the method of accessing the UI file. UI dot start frequency underscore input dot text, and this imports the file as a QString text variable. then you have to change that variable to a float. So I just redefined it itself as a float. And I did this for the end frequency, I did this for the frequency interval, and here you just see the calculation to actually find out how many intervals you have. This is the same thing I did before. I defined the frequency array, which we're going to be defining. And this is also the same as I defined earlier in the last video, part E3. This is also the same, but you notice here, look, every time I have a I have my function, my custom Picoscope function, I write fn.getMeasurements, and you see here another space, fn.timebase, and I define that frequency fn dot. So I just write fn dot and following by the function and its proper inputs, and we pretty much have the same thing going on. Here I define the header just like before. In order to get the file name, I capture the file name text box right here. And the thing is, when you actually capture it, which is right here, you actually don't get a string file, you get a Q string file, which has something more similar to a to its internal, Qt user interface style. So you have to create a string from that string, which is more local to the Python. So I add .csv because I'm doing a CSV program. This is again n.saveText. I'm actually saving it to a file. I have all of these as my functions, and I have my delimiter, which is a comma, and my header, which is equals head, which is here. I defined already, and you define that with commas as well. Next, I'm going to populate the graph. Now, graphing in UIs are a little bit complicated, not so fun. It's slow, especially in comparison to LabVIEW, but for all practical purposes, you don't need to be updating your plot every time. Just update it at the very end, or you can update it every time if you really want to. But here's just a simple way to understand that without doing any modifications to the plot. You'd write .ui. UI dot matplotWidget, and matplotWidget is actually the name, which is the default name for this. I could have changed this name to anything. I could write impedance plot or whatever, but it's called matplotlibWidget. So I'm going to call that matplot.widget. No, sorry, ui.matplotlibWidget.access.plot. This is a standard protocol in order to access that, and I assign the frequency space for the x and 1 over impedance in order to highlight the resonance phenomenon, because obviously when you're looking at impedance, anti-resonance dominates on a scale. However, in order for you to you can either plot admittance, which is 1 over impedance, which I just did here. So I actually plotted admittance, which is 1 over the impedance, and then I .matplot.draw, and that puts that that updates the plot. The next part, I think I'm running out of parts here. Link buttons. I think I added an extra part somewhere or another. Sorry, there should have been section 3. Okay, then this should be section 4. And then section 5 is this, where you link the GUI button. So section 5 of this code is where I link it. So basically, I have to tell what happens when you click the start button. UI.startButton, which accesses the start button. .clicked, which shows it's clicked, what happens. And write connect. Okay, what function doesn't run when you connect? And you can define start. This is a very simple program. Something's missing, and I don't. You can look up the different ways online and how to access the Python things. For example, what I mean is that, for example, if you can also define something that happens when you click the file name. If I for example, if I have the program running, the file name widget, I could say you can give an instruction, let's say an instruction box or something that pops up. There's a lot of different events which could happen. Something where you could hover over the start button and something, a certain function executes. You can click it and a certain function executes. You can double click, something happens, or if you hover over one of these text boxes, something happens. Text changes, appears, disappears, or some function runs, or and anything really could you could work, you could implement, but you need to read more into the user guidelines, which are online. You can search for Python PyQt. You can search for these different buttons which are there. For example, we have here we have what's called a let's look. We have line edit, so you can look up the different functions which are available for line edit, and these are the exact sort of names which come out. So you can search those up online. But I basically showed here these few steps, which I'm just going to post here in a text box. So we showed a couple different steps. I described the outline of the file of this lesson, which is here. Here's the outline, and these are the different sections of code which exist. I think I forgot to say, and this is this is the way you close out the program, which is something standard which you're not going to change. So when you actually implement this, and you should make sure it works. After a couple seconds, this pops up, and it saves. You press start. It starts taking all the data, just like it did in the previous lecture E3, lecture project 1 E3. It starts iterating through that. When everything's done, it gives a plot here, and also saves your data to a file. And I'll just show what that file looked like. I think you saw it earlier from the last lecture, but let's just go through it real quickly. Let me just get that for you. It's going to be in Picoscope. And for this program, it saves that file underneath the same name. So I click on this file. I didn't change the file. And then I have this. I have it as a CSV. You can also save it back as an Excel file, so that your changes to the file that you do in Excel, for example, plots and calculations that you do in Excel, are going to be saved as well. So thanks for watching. Today I explained how you practically and most easily implement a GUI in Python to work with functions defined to operate the Picoscope, and also we wrote a file. So we're going to post those two. So in this folder, this file, I'm going to post two different. So in this here, we're going to describe functions.py, and it's going to be lowercase. You have to call it lower one folder. So functions.py, that would be there. So I'm just going to go ahead and paste these in here. You can end the video, or you can just watch how I do it. But that's all for today. Thanks for watching. I'm just going to be copying and pasting these in there. So feel free to jump to the next lecture, which is not available yet, but will be soon. I'm going to, in the next lecture, we are going to actually start back on our experimental side, where we are going to attach our piezoelectric transducer to a small metal cup, which will be used to sonicate, and we'll use that for characterization, and then furthermore we'll keep marching forward with our goal to clean something with this transducer. Okay, thanks for watching. I'll just copy all this in there. So you save this in your same file. You may need to download an extra program to work with PyUIC4. And remember, before you start your program, you need to open Picoscope, which is sort of like a given, but you may forget. I'm also going to throw in the UI file. I am going to just open that up for you. So this is what the UI file actually does. We're going to then insert. The Qt designer creates this UI file, Picoscope UI.UI. Make sure you have that nice extension, not a txt by accident. So I copied it, and then I'm going to insert a text box here. And obviously, you can email me or reach out to me however you deem fit in order to ask about all this. And I'm also going to just, on the next slide, it's going to take this and send to a compressed zip file. I'm just gonna pop that in here. I'm just gonna put that there. So you have your zip file there if you want to access it. So I'll write complete zip file as well. So you have everything. Okay, thanks for watching. Look forward to seeing you in the next lecture, where I will attach a transducer. We're done with programming for now. There's a lot more I could discuss. There's a ton more to discuss, but I'm done for now. We're going to go lecture not E, but lecture F. Thanks for watching.